Welcome back and thank you for joining me. So in this section, we're going to talk about the fourth and final way we're going to factor in this section. Today's the first time we're going to factor quartic functions. So remember, when I say quartic, I mean things that are in the fourth degree. Now, we're only targeting specific quartic functions though. Quartic functions that are of this type, where you have a term to the fourth degree, second degree, and a constant. Because when they're in that form, we can factor just like we've been factoring quadratics. We end up with something that looks just like this. And then we solve, once we factor, exactly the same way as we have been the first 3 days we've done this section. So let's jump right into this first one. And again, the biggest thing that I notice is that I have that fourth power, that squared term, and the constant. So what that means, to get an x to the fourth power, that means both of these have to be x squared instead of just x's. That's how I end up with a quartic instead of a quadratic. Now from there, we actually get exactly the same thing. The last two numbers I'm looking for need to multiply to 9 and add to negative 10. Well, again, when this number is negative, that's telling me I have positive. When this number is positive, it means I'm looking for two numbers of the same sign, and that tells me that sign is negative. So the only way to make this work is to have a negative 9 and a negative 1. So again, the factoring isn't that difficult. The only thing you have to know is that you're dealing with x squared instead of just x's as you're factoring. And now both of these, we solve independently using the zero product property. So x squared minus 9 equals 0. X squared minus 1 equals 0. So solve by square rooting. I can add the 9 over. Then when I go to square root both sides, remember you always end up with that plus and minus. So here I get a plus and minus 3. Then on this side, when I add the 1 over and I go to square root it, I end up with plus and minus 1. So notice for these quartic ones, I'm getting 4 solutions, plus and minus 3 and plus and minus 1. And that's going to be the basis for all the ones that we're factoring today. You're going to be getting 4 solutions from this factoring process. Let's take a look at this next one. So again, what I notice, I have an x to the fourth term, that squared term, and the constant. So what that means when I'm factoring this, I set up with x squareds first. Now I'm looking for two numbers that multiply to 12 and add to 7. So what I'm going to be looking for is 4 and 3. So I factored just like I would a quadratic. And now I go and I use the zero product property. Luckily, both of these are going to be able to be solved by square rooting. I have to subtract the 4 over. And now I go to square root both sides. Remember, that gives me a plus or minus. Square root of 4 is 2. And then because I'm square rooting a negative number, remember that means I'm always going to get that I paired with it. Then on this side, I'm going to subtract the 3. And again, now I can solve by square rooting. So I go to square root both sides, get my plus or minus. Square root of 3 doesn't really simplify, so I'll make sure I put the imaginary piece first because I'm square rooting a negative. But then square root of 3 just has to stay as is. And then those are going to be our 4 solutions. So this is going to be the pattern, again, for everything that I'm asking you to do today. You're going to get 2 parentheses that can both be solved by square rooting, and then you're going to get your 4 answers that way. So remember, when you're factoring, we talked about this, I think, 2 lessons ago, that you need to make sure that it's set equal to 0. Right? You have to have everything on the same side. So before I can start this process, I need to make sure that I subtract that 25 over so it equals 0. And now I'm going to be ready to set up my factoring process. To get x to the 4, again, you always are going to end up with x squared and x squared today. Multiplying to negative 25, adding to negative 24. So what that looks like is that's going to be a minus 25 and a plus 1. Once you get that factoring down, now I'm going to take each of those pieces and set it equal to 0. These are always going to be able to be solved by square rooting, but the key is remembering when you square root them, you need to remember the plus and minus and if it's going to be an imaginary number or not. Here, I'm square rooting a positive number, so I legitimately just get plus or minus 5. However, for this other one, when I subtract the 1 over, now I'm going to be square rooting a negative number. And remember, whenever you square root a negative number, that's when you get your imaginary piece. And because the square root of 1 is just 1, I don't really need to show that because I already have the I there. So that's 1I. And that's going to be my 4 solutions. And our last one, again, we need to make sure it's set equal to 0. So I'm going to add that 49 over. I'm going to set up my parentheses. So to get x to the 4, I'm going to need x squared and x squared. Two things that multiply to 49 and add to negative 14. Well, this tells me they have to be the same sign, and that sign is going to be negative. So I believe it's going to be x squared minus 7 and x squared minus 7, because those will multiply to be positive 49 and add to negative 14. Now, just like before, when you had two of the same things, I don't expect you to solve it twice, because solving it once, well, you're going to get the answer. So all you have to do is solve this once. Add the 7 over, square root both of them. Well, I'm square rooting a positive number, so I don't need the imaginary piece, but it's going to be plus or minus the square root of 7. Now let's think back. I think it was in 5-2. So because this parenthesis is represented twice, what this really means is that both of these have a multiplicity of 2, because that factor was represented twice. So that's why even though you're getting only 2 answers here, really is representing all 4 because it has a multiplicity of 2. So those are all the examples I'm going to throw at you today. So I'd like you to write a summary because now you've gone through all 4 factoring methods. So I want you in your summaries to write for me, please, how you're going to keep those 4 factoring methods straight, because it is going to be key for your test, making sure you know which method to use. So I'd like that to be the focus of your summary. How are we going to tell these apart when I'm asking you to factor all of them? So write that summary for me and then come back to class. You're ready to do your practice work, please.